Hello, I'm Bruce Samuels, Interventional Cardiology from Cedars-Sinai Medical Center in Los Angeles. I'm here with
Erick Schampaert from Sacré-Cœur Hospital.
So we've been asked to talk to you guys today about QFR and whether angio-based physiology systems will be a revolution to replace wire-based technology. So for the sake of being provocative, I think I'll take the position that yes, this is here to stay. And Erick's going to take the counter position that maybe it's not ready for prime time yet.
Correct.
So maybe we can start out by just talking a little bit about what these systems are. I think a lot of people around the world have heard about them, but are not really using them in their labs yet. In the United States, there's one system which is commercially available, at least in California, where it started already a commercial rollout called CathWorks. But I know there are several others in Europe and outside of the US that are available. Do you have them in Canada yet?
No, currently none of them is available. I think also for sake of clearness, people should know that there are basically two approaches. One is non-invasive assessment using, for instance, coronary CT to try to get information about physiology derived from anatomy. And the question at hand today, the QFR, which is based on angiography, so you need to have an invasive coronary angiogram performed. And these data are used to derive from anatomy, coronary physiology, as one would get with invasive interrogation with a pressure wire, for instance.
Correct. So we're talking about these systems in which you have to bring the patient into the cath lab.
Correct.
You can take the angiogram and based on the angiogram alone, get an assessment of a pressure drop across a coronary lesion, right?
Yes.
So at Cedars, we've had quite a bit of experience with the CathWorks system. We were the first in the world to get it actually installed in the lab and have done several hundred cases. In Europe, they've had quite a bit of experience with the METIS and the PI system. But those, though they're FDA approved, are not quite available yet, but they are coming. And this is definitely a technology which is here. And I think over the next few years, we're going to see not just one, but several of these companies come into the lab and ask us, you know, can we use this technology instead of a wire? Because of course, to use them as an adjunct to a wire would be duplicative and would cost a lot of money. So I'm going to let you start and tell us, you know, how you feel about that.
Well, the way I see the available evidence so far, the different companies have been able to do some validation, comparing invasive assessment in the same patients with derived images from the coronary angiograms data. Depending on the group of patients that have been addressed, most of them looking at what I understand being single lesions, fairly simple disease, correlations have been quite good. The published available data is quite supportive that most of these systems in sets of patients that have been studied reliably provide correlation in the 90s in cases where the angiogram was properly performed. Where I see the limitation is the current data regarding the use of FFR being used as the gold standard in these systems validations has provided some limitations over the years, so that patients with diffuse disease, tandem lesions may not be well assessed by FFR with hyperemia, and where resting indices, and IFR in particular, seems to have a potential superiority in terms of its ability to assess these lesions. And so if one starts to use outside of the set of patients that were assessed and validated with QFR, for instance, into more complex disease, the correlation possibly at the end of the vessel would be still quite reliable, but the disease distribution and pattern of physiology change over the course of the vessel may not be that reliable.
This is going to be a very difficult debate because I can see we agree too much. But let me take a step back and talk about exactly how angio-based systems work, because the science is actually very interesting. So while wire-based of course, is based on a a pressure transducer, which is directly measuring pressure across a coronary bed. What these systems do is they use a lump sum parameter model, which is a fancy way of saying it's modeled after an electrical circuit, and the branches that occur with the loss of pressure across resistances. And so basically you're turning the coronary tree into an electrical circuit with the changes in resistance that occur from a coronary lesion. And with every branch point, you're talking about that electricity moving in series or in parallel. And based on assumptions that are made of input and output from those branches, the coronary tree is modeled in order to get as accurate an assessment as possible for all the input and output. And then the narrowings or the caliber of the coronary artery is used to model the resistances. And based on that, you can, using Ohm's law, figure out how the pressure drops across the coronary lesion. So I think the science is actually quite good.
In a theoretical model.
In a theoretical model, right. But the issue with all of these angio-based systems is it becomes garbage in and garbage out. You have to have beautiful coronary angios in order to have a good assessment. Because if you don't have good coronary angios, you're not going to get a good 3D reconstruction of that coronary tree. And there's a lot of debate about whether one view is sufficient, 2 views is better, 3 views is better. Some of these systems use 2 views, some use 3 views. Often when you have 3 views, you don't get all 3 views good enough and the computer throws one out. So I do have still some questions about whether or not the modeling of the coronary tree is as beautiful every time as they would like it to be. And of course, the edge determination is very critical. The computer will always give you those edge modeling, but then it's up to you to fix
Tweak
that.
it, yes.
And so an unethical doctor could tweak it in a way to make the stenosis tighter, and of course the FFR will change. So this is, I think, a real important issue. Is one is garbage in, garbage out. You have to have good quality images. But the other is, this is a system which requires human interaction, whereas the wire does not require much human interaction. A little bit to make sure you get good quality tracings, but for the most part you press a button and it gives you a number. Here there is a strong requirement to have human interaction. I think this is, for me, even though I love the science and I think that this is here to stay, and it's probably quite valid as a means of measuring coronary pressure, the key is that it's very difficult right now in these first generation systems to get a number that you can trust and be sure about, unless you are very skilled at using the computer doing the workflow.
Yes.
And so because it takes a lot of time, energy, and human attention, a lot of physicians are nervous that the number they get at the end of the study is as reliable as the number they get with the wire. But, and this is the big but, it will get better. It's only software.
Yes.
All you have to do is make the computer smarter and make it run faster.
Yes.
And then eventually we'll get to a point where I think people will accept it.
One potential limitations that I see is not taken into account, even in modeling system where they use myocardial mass assumption to better calibrate their fluid dynamics equations, sorry, is the fact that we don't know if this myocardial mass is viable or not.
That's very true.
And there may be patients where scar tissue is present prior MI, and the system would then potentially overestimate the physiological impact of a disease.
I think that's a great point. Myocardial mass in these lump sum parameter models are based on the 3D reconstructive tree, whereas in the CT FFR, they're actually based on a direct measurement of myocardial mass. But it is true, of course, that you could have a dead myocardial mass, and therefore the invasive FFR could be affected by that too, because you don't have as much...
but it would give you an appropriate evaluation still of the blood flow needed for that residual tissue.
Yes, true. So it's a great point, because this FFR that you get with angio-based systems is a assumed hyperemia. And I think that's very interesting and probably has a lot of great potential for study in evaluating different kinds of coronary subsets where you have hyperemia assumed and hyperemia induced, and see what the differences are.
Well, The future looks bright.
Yes, I think so. Good, we agree on that.
Thank you.